Okay, I've started the recording. Apologies for the delay. There was a religious function at home. Can I see everyone, please? Video on. Okay, all right. Rohan, is it all right? A couple of questions you had mentioned. Can we take it offline a little bit later?
Yes.
Okay. So, Kunal, when as feasible, turn on your video. So let's discuss the homework from last time. It's mostly on quadratics. Okay. All right. Are you able to see my screen, or am I not sharing yet? Not sharing yet. Okay. Apurva, you able to see, right, my screen?
Yes, sir.
Okay. Apurva, did you do the first one? Can you get it started on the first one?
So actually, I was not able to attempt the homework this time.
As in you didn't get time, or?
Yeah. So I
Okay.
didn't get time. I had
All
like
right.
a trip this week as well. So
Okay. All right. Rohan, how about you?
Sir, I did not either, but I can do it right now. I'll do it right now.
Okay. All right. You do it right now. I'll pass it on to someone else. Kunsh?
I don't know why, but I don't see the homework when I open WhatsApp.
What do you mean?
I just switched phones. I think it might be a result of that. I can send you a screenshot.
Kunsh,
I genuinely don't see it.
I have to give it to you. Every time you have some bahana or other. Okay, guys, you have to take your homework seriously, guys. That's how you practice. Okay, I know
So
all
I
of you
can
have
answer
so
the
many
first
things.
question.
Okay, all right, Rohan, can you help with the first one then? Yeah.
Okay, the x-intercepts are -2 and 1. You just flip the sign.
Yeah. So, yeah, we'll okay. One after the other. So x-intercepts are -1 and 1 because that's what causes this expression to be 0, right? Okay. All right. Go
Yeah.
ahead. Yeah. So -2 and 1.
Okay, for B, I'll have to expand it.
No, you don't have to expand it. So -2 and 1 are the
Okay, you
roots.
can take the mean, you can take the average. Correct, sorry. Like of
Exactly.
the x values.
Yeah. Does it make sense? Apurva, does it make sense? Why the x-intercepts are -2 and 1?
yeah, because wherever the parabola cuts the x-axis is
Correct.
where it's 0. So that means those are the x-intercepts.
Correct. And the equation of the axis of symmetry, hold on 1 second, Rohan. Why would it be the average, Apurva?
Because so the axis of symmetry is basically like the vertical line that you draw from the vertex, right?
Exactly.
And the vertex is in the middle of the two x-intercepts.
Perfect. Yes. So it'll be halfway between -2 and 1, which will be around x equal to -half, right? The average of these two. Okay. All right. Continue, Rohan. X equal to -half is the equation of the axis of symmetry. Average of -2 and 1. Okay. C part. Y-intercept.
Just plug in x equals 0. So you get -2 times 2 times -1. I think that's 4.
That's 4. So passes through 0, 4. So
Yeah.
we know it passes through 0, 4. Let's say that 0, 4 is somewhere here. This is y-axis. Okay. All right. And then find
And
the
then
coordinates of the vertex.
you plug in x is equal to -half. So that's 1.5 and -3/2. Oh,
It's all
yeah.
it's
minus
all
1.5 and
1. It's always be the same. So when you plug the vertex, both of these will be same except opposite signage. So if you know this is 1.5, automatically you should know the other one is -1.5. Yes, correct. So -2 into 3/2 into -3/2, correct? So how much does that work out to? 9/2, I guess, 4.5. Yeah. All right. So now you have all the information. Now to sketch the function, it's downward going because the x-square coefficient is negative. So you have all these data points and you can just connect them all and you can draw a graph, sketch a graph like this.
does AMC ask questions where to sketch it and all?
No, it doesn't. It doesn't. I want you guys to get practice, right? All of this is just practice, right? It doesn't. AMC is all multiple choice. But given a graph like this, for example, you should be able to, I think there is one later, right? Given a graph, you should be able to identify the equation of that, right? That could be fair game. Yeah. Okay, Avinash, you want to take the question 2? Complete the square.
Question 2. Okay, sir.
Did you attempt it?
Yes, sir.
Okay, help me, please.
So the first thing I did is that I did x square plus 7x plus 49/4.
Okay,
in
where
my
did the
bracket.
49 upon 4 come? Because the
2ab is equal to 7x. So that's how I got 49 upon 4 is equal to b.
correct. So 7
B
by 2
square,
is your
sorry.
missing. Yeah, 7 by 2 is the missing piece that if I add
Yeah.
7 by 2 whole square on both sides. Okay. All right.
So then you have to do -4 minus 49 upon 4, right?
Or bring the 49 upon 4 to the right side. That way it's safer. Right.
Yeah.
Then with minus 7 by 2, there's always confusion with plus and minus, right? So this is
Mm.
x plus 7 by 2 whole square
Mhm.
and equals 4 minus 49 by 4, I guess, right? Or 4 plus 49 by 4,
4 plus on that side.
right?
Yeah.
Which is 65 by 4.
Yes.
Okay. And
So
therefore,
I just got x plus 7 by 2 upon minus 65 by 4, and then you just go and do the root on the other side and get x. Yeah.
perfect. Just standard book work, just for practice. Minus 7 plus
Yes.
or minus root 65 by 4. Of course, if you use the quadratic formula also, you should get the same thing. Minus b plus or minus square root of b square minus 4 into a into c, right? Whole upon 2a. That also give, this will be again minus 16 or plus 16, whatever. And therefore it is same as this. Okay, sounds good. Ananya, question 3, maximum and minimum value of this. Maximum or minimum value. First of all, will it be maximum or minimum?
So I don't know.
Why? This is basic quadratic that we covered, right? For a quadratic, what is the maximum? Kunsh, you want to take this? Even though you have not done it, can I do it now? What is the maximum or minimum for a quadratic?
So if it's negative, then be a maximum value.
Yeah.
If the coefficient of the x squared.
Exactly. So this will be coefficient of x square is negative, therefore it will be downward going. And therefore this vertex Ananya will be the maximum. Does it make sense? Okay. Continue, Kunsh. Therefore,
Therefore, we have to find the maximum value.
maximum
Right.
value and the value of x at which it occurs, which means effectively we have to find the coordinates of the vertex. Okay. So what are the coordinates
Yeah.
of the vertex in terms of a, b, and c? Or ax square plus bx plus c? Yes, go ahead, please.
So I got so y is equal to 5 and x is equal to 1.
Okay. How did you get the x equal to 1?
So root like a quadratic number.
Sorry, what quadratic? So this is a quadratic function, yes. So how do you get the vertex coordinates?
I found out the roots and then I found out the average.
Not needed at all. You can direct, yeah, that's also fine. Minus b by 2a. So minus b by 2a, right? So which is 1. And if you plug 1, do you get 5? That I'm not sure. 4 plus 3 is 7, minus 2 is 5, indeed. Yeah. So 1,5, you are right. But you don't need to find the roots. In the previous question, when Rohan was going to do that, I said you don't have to do it because you already have the roots. If you have the roots, you can directly take the average. If you don't have the roots, you can directly do minus b by 2a. Because the roots are, what is it, minus b by 2a. And the roots are on either side of them, right? Which is why the average of the two roots becomes the vertex. This is the vertex. And with the plus or minus, you have the roots on either side. Does it make sense? Okay, sounds good. Question 4. Yeah, the sum of a number and reciprocal is 2 1 by 30. Who wants to help with this? Anahat, did he do this one? Question 4.
No, I did, but once I don't have my book, I just joined.
Okay, all right. Kunal, meanwhile, you want to help with this? Did he do this? Question 4.
No, sir. Sorry, I didn't get time to do the sums this week.
Okay, who has an answer? Rohan, you have one for this?
I can do it with you right now.
So I've
Okay.
done it, yes.
Okay, whoever has done it, can you call out, please? Avinash, what did you get?
So 5 by 6 or 6 by 5, one of them.
5 by 6 or 6 by 5. Okay, Rohan, continue doing it meanwhile.
So I
Meanwhile,
also got
we'll
the same answer.
you also got the same thing. Okay, all right, let's do it for completeness. X plus 1 by x is 61 by 30. Multiply throughout by x, 61 by 30 x. And multiply throughout by 30, that makes it easier. So 30, and this is 30. And get us as a quadratic, 30x square minus 61x plus 30 equal to 0. Okay, so we have to guess two numbers that add up to minus 61, and multiply to give 900, right? 30 times 30. So it might be difficult to guess, given these are big numbers. We can resort to minus b plus or minus, right? And no calculator, but we can still do it because 4 into 30 into 30, right? Whole upon 2a. So 61 square, you can use 60 plus 1 whole square. Without calculator, we can do this. 3600 plus 2ab is 120 plus 1, which is 3721. 4 times 30 times 30 is 900 times 4, which is 3600. If I subtract, I get the 121, right? This is the 121. So we have 61 plus or minus 11 upon 60. Yeah, you're right. 50 by 60, which is 5 by 6, or 72 by 60, which is 6 by 5. And as expected, because 5 by 6 and 6 by 5 are reciprocals of each other. If 5 by 6 is an answer, obviously 6 by 5 will be an answer. They're reciprocals of each other. Okay. Back to, was it Kunsh or was asking this question or someone, right? In AMC, do we have, oh no, actually Avinash was asking, right? A question could be something like this. Given a graph, they might ask you, what is this graph, right? Avinash, were you able to do this one? Question 5?
Yes, sir.
Okay. You want to take one of them, the first one?
So I'll take the second one. The first one I didn't fully expand it.
Okay, take the first one. Second one, yes, go ahead.
Taking the third one.
B. Okay, go ahead with the B.
So wait, let me.
You don't have to fully expand. You can leave it in any form. It's fine.
I got minus 2 by 7 into x minus 1 into x minus 7.
Okay. Okay, let's verify this. So the axis of symmetry is given at x equal to 4, which means this point is 4. One root is on this side at 3 units away from here. So the other will be 3 units away from here. So it will be a 1, right? So 1 and 7 symmetrically placed around 4. So you are right with this part, x minus 1 and x minus 7. And then we just have to find the a. And we do expect a to be a negative number because it's downward going. And we can use the fact that it passes through the y-intercept of minus 2, which means if I plug in x as 0, I'm supposed to get y as minus 2. And that indeed gives a as minus 2 by 7. So you can leave the answer in this form. That's perfectly fine, right? Any form. You don't have to
You have to fully get it in the quadratic form.
This is a factorized form. You can leave it in the 3 different forms, right? You can leave it in the factorized form or the normal ax square plus bx plus c, or you can also leave it in the vertex form. Either one of them is okay, right? Okay. Ananya, you want to take this one? A.
So I got 20 into x plus 1 into x minus 2.
X 20 into x plus 1 into x minus 2. X minus 2 like this?
Yes, sir.
Okay, so clearly that's wrong because I see 5 is a root. But if this expression is this, then 5 is not a root. Minus 1 and 2 are the roots. Does it make sense? Okay, so very obviously there's something is wrong. We could check, right? Anyone else? Kunal? Oh, Kunal, you said you did not do this.
Yes, I got this one.
Okay, what did you get, Anahat?
20 upon 9, x minus 5, x plus 1.
X minus 1, you said? X plus 1?
X minus 5, x plus 1.
Okay, x plus 1, x minus 5. Okay, okay, so 2 is the vertex. So same logic. This is 3 units this way. So 3 units to the left of 2 would be minus 1. So x plus 1 and x minus 5 would be the factorized form. So we don't know what the coefficient is. So again, we can use one information that's given, which is it passes through 2 comma minus 20. So when I plug x is 2, I should get 2 plus 1, 2 minus 5, right? I do get a as 20 by 9. A is 20 by 9. So yes, you can leave it in this form. Perfect. Okay. Avinash, you want, not Avinash, Rohan, can you help with the C part?
Sir, I not done it, but minus 3 is also the vertex. You could use vertex form.
Okay, go ahead, please.
It's x plus 3 the whole squared.
X plus 3 the whole square.
And then we can sub in 0, 2, but we have to put plus k.
Plus k. And what is k?
It's the y value for the
Which is
0.
exactly right. So the vertex form is a times x minus h whole square plus k.
Oh, then
right?
we have to add the a as well.
Yeah,
right?
you should add the a, correct, right? And h is actually here minus 3. Therefore, what he is doing is he's doing this,
Yeah,
and then
plus.
k is 0. So he is noting that the vertex is minus 3 comma 0. Okay, continue.
Now we can plug 0, 2 to get the value of a.
Exactly. So a times 0, 2, right? So it's 3 square,
3 squared,
right?
and that's
And
2 by 9.
2 by 9. So it's 2 by 9 times x plus 3 whole
So
square.
3 the whole square, yeah.
Okay. Understood? Fairly straightforward, right? Basic stuff. Okay. Question 6. Okay. Apurva, did you attempt question? Oh, you said you didn't have time to attempt anything. Avinash, did you attempt question 6?
No,
Sorry, I didn't hear that. Yes or no?
no.
Okay. Or you
Sir?
attempted, but you could not get it. Yes, Rohan. Yeah.
Here, I think you would use the conjugate to solve, right?
Exactly. Multiply the denominator by the conjugate. Okay, so let's try to do that. So the conjugate root 2 plus root 3.
Sir,
I can either.
got 9.
Sorry, say that again.
So I got 9.
9 is the final answer. Okay, yeah, let's check. Okay, so the conjugate of root 2 plus root 3, you can either treat it as root 2 minus root 3, although root 2 minus root 3 is negative, or root 3 minus root 2. I prefer the latter, even though he has given it as root 2 plus root 3. I can write it as root 3 plus root 2, right? But whatever it is, it should not matter. If I multiply by root 3 minus root 2, then this becomes root 3 plus root
Yeah,
2.
I got 9 as well.
Okay, times root 3 minus root 2. And in the numerator, I have root 3 minus root 2. I'm multiplying by the conjugate. So what happens? This becomes a square minus b square, right? So it becomes 3 minus 2, which is 1. So the same thing for every denominator, since these roots are separated by 1, right? A square minus b square will be 1, 1, 1 everywhere. And the numerator will work out to be root 3 minus root 2 here. Here it will be root 4 minus root 3. Here it will be root 2 minus root 1. Right? And so on. And we have this telescopic cancellation, right? Root 100 minus root 99. Whenever we have these, everything will cancel except the very first term and very last term. I mean, yeah, very first term meaning in the very first term, you have to be careful which term. In this case, root 2 cancels, but root 1 prevails, right? Root 3 cancels, root 4 will cancel, everything will cancel, root 99 will cancel. The prevailing terms will be the extremes, root 100 minus root 1. Yeah, which indeed is 10 minus 1, which is 9. Okay, and the B part for this was an extension. Instead of 99 and 100, I think he gave root 10 and root n plus 1. So same thing, right? So instead of root 100, it'll be replaced with root n plus 1. That's the only difference. Okay, minus 1. Okay, all clear? Avinash, is this clear? Apurva? Yeah, all good. Okay, question 7. Question 7.
So can you just show the B part, the question once?
Oh, you have this thing, right? Or I can show it, not a problem. But all of you have the PDFs independently also, right? Whether I'm sharing or not. This is the B part. So n belongs to z plus. Z is integers, z plus is positive integers. So he's just replacing n with 99. That's the only difference. Okay.
Okay.
Question 7, which is your solving your modulus problem. Okay. Anyone has an answer for this? Or yes,
I
go ahead.
got, minus 1 by x is greater than minus 1 by 5 and less than 3.
Okay, all right. I write it this way: minus 1 by 5 to 3. Okay, this is Ananya's answer. Okay, anyone else? Or can you guys take time to do it, since many of you have not done it? Can you guys take a minute to do this? We'll discuss. Okay, Ananya, straight away, I can tell you it's wrong. I mean, straight away meaning, see, whenever you have an answer, do some basic checks. For example, if I put x equal to, I don't know, 1000, let's say, right? Then the numerator is approximately 3000.
It's not fully wrong. The signs are wrong. Otherwise, the roots are correct.
Okay, whatever it is.
At least
Okay, so I'm just saying, right? The wrong is wrong, right? So maybe it's just that. But my message to Ananya and everyone is do some basic check, right? Just check some extreme values. If x is 1000, then this is approximately 3, which is greater than 2. But according to your solution, x equal to 1000 will not occur, right? So can you check your working, Ananya? Does it make sense? Make sense how to check also, right, Ananya? Generally. So Avinash, so you have an answer too, Avinash, then? What is your answer, Avinash?
So my answer, I just got it. Minus 1/5 is greater than x, and x is greater than 3.
Minus 1/5 is greater than x. So which means, in other words, x is less than minus 1/5.
Yeah, and x is greater than 3.
You have to be careful. If you say this, that means there is no x. You mean or, but you've called it out as and.
Oh,
Right? I'm being nitpicky, but it's important. If you write this is like saying there's no x, effectively, because you want such an x which satisfies both, which is impossible, right? But I know what you mean. You mean this, right? You mean or. Okay, fine. That's your answer. We could check. Okay. Again, very easily I can say you're wrong, because again, let me put minus 100 or something. The numerator is a clear negative. The denominator is a clear positive number. So how is it greater than 2? No, right, Avinash? If you're saying x is less than minus 1/5, then x equal to minus 100 should be acceptable. Same sense check. Yeah, Avinash, agree with me?
yes.
So
Yes, Apurva.
isn't it just like x is greater than 3?
X is greater than 3. Okay, all right.
Because any negative number in the numerator will become negative, and because of the modulus in the denominator, you'll get a positive number, which means you get a negative answer overall. Should be less than 2.
Okay, I like your logic that clearly the moment x goes below 1/3, we are talking about a negative number on the left hand side. So not possible. Okay, but convincingly, can you say x greater than 3? I understand your logic.
So just
But-
1 second, let me just
Yeah.
work it out. I'll double check
For,
it.
yeah, for example, tomorrow I might change this question. I'll say this is greater than minus 5. Then how will you do it, right? Okay, so you should be able to have a convincing way of doing any problem.
If
But
you,
I like your
Yeah.
intuition. Yes. Go ahead, Rohan.
no.
Anahat, anything from your side?
I also got x is greater than 3, but I'm just figuring out this thing. The
Okay.
full-
Shall we discuss, guys? Rohan, you got something yet, or
I got the same answer as Avinash, I think.
okay?
X
Let's
is
discuss.
greater than 3 and x is less than 1/5.
But x is less than 1/5. Do you agree it's wrong?
Yeah, because I
Right?
plugged in and checked.
Okay, yeah. So we have to check then why it's wrong, right? So you have an inequality here. I can safely multiply mod of x plus 1 to this side because I know mod of x plus 1 is a positive quantity. So first of all, x cannot be minus 1. So we'll put that up front, because if x were minus 1, the denominator will have a 0, which is not possible. So x plus 1 modulus is greater than 0. Therefore, there is no sign change. I can write it as this. Right? Now, any modulus problem, divide the problem into 2 parts. Right? Where does x plus 1 become 0? It becomes 0 when x equal to minus 1. So to the left of minus 1, this one region, and right of minus 1 is another region. Normally, we'll put equal to 1 somewhere, either on the left side or the right side. But in this case, we know x cannot be minus 1, because in the given problem, mod of x plus 1 is in the denominator. Had the problem been this, right? What I've stated here, what I've marked here, then x can be minus 1. There's no denominator. So there's a small difference between the given problem and the first step that I have. So in the first step that I have, I'm okay with x being minus 1, right? But in the given question, x cannot be minus 1. So now that I've made a note that x cannot be minus 1, I'll remove the equality sign here. Now I've divided up into two cases, right? When x is less than minus 1, that means what? X plus 1 is negative. If x plus 1 is negative, anything is negative, then modulus of that is negative of that quantity. That's how we studied, right? Kunal, you always get confused with this one. You're okay on this one now?
Yeah, now I got it.
Okay, so the problem reduces to 3x minus 1 is greater than 2 times minus of x plus 1. So minus of x plus 1 like this, right? So in this region, it's a problem which is this without modulus. Now without modulus, I know how to do it very easily, right? So I'll bring the minus 2x to this side. I'll bring the minus 1 to the side. Minus 2 plus 1 will become minus 1. And I'll say x is greater than minus 1 by 5. So I will conclude by saying in the region where x is less than minus 1, so minus 1 is here, minus 1 by 5 is here. When I'm looking at all the x's which are less than minus 1, I'll accept any answer which is greater than minus 1 by 5. And there is no such x which will satisfy that. And therefore, I'll say no solution in this part. Right? I'll repeat again. In this left half, I'm operating at only numbers which are less than minus 1. So I only look at numbers which are less than minus 1, and I'm finding that the answer is x greater than minus 1 by 5. There's no x which will satisfy, right? Similarly, I'll move on to x greater than minus 1. In the region x greater than minus 1, x plus 1 is greater than 0. Therefore, modulus of x plus 1 is just x plus 1 itself. I don't need the modulus sign. So the problem simply becomes greater than 2 times, just simple bracket 2 times x plus 1, which again, I can arrange it, bringing x to one side. So 2 plus 1 is 3. So x greater than 3. So what is the story here? Here I'll say, when I'm looking at x values greater than minus 1, I'll accept all answers which are greater than 3, which means the intersection is only numbers which are greater than 3. The commonality between this and this is x is greater than 3. Right? And for the left half, it was no solution. So when I put both of them together, the final answer is x greater than 3. Now, for example, I'm just saying, for example, had the left half worked out to be for x less than minus 1, I'll look at answers which are less than minus 4, something like that, right? Then you will say x less than minus 4 is the answer here. X greater than 3 is the answer on this side. I'll bring both of them together, and then I'll say I'll accept either x is less than minus 4 or x greater than 3. That's how I'll finish it. Of course, in this question, there's no solution. There's no x less than minus 4. There's no solution. So I'll say either no solution or x greater than 3, which effectively means x is greater than 3. So you should know how to combine different parts. Here it's and, right? You want both x greater than minus 1 to satisfy and x greater than 3 to satisfy, which is why it's an and condition between these two. Similarly, it's an and condition between these two. You want x to be less than minus 1 and you want x to be greater than minus 1 by 5, which is why the and is telling there's no answer at all. And then finally, you combine this result, which is a no solution, and this result, which is x greater than 3, and then finally conclude it's x greater than 3. So putting together this stuff is very important, guys. Okay, Anahat, you're completely sure on this one, right?
Yeah.
Okay, all right, cool. Everyone is convinced on this one. Ananya, you're okay?
Like in the left side, the inequality, like when you are taking minus x plus 1 to the other side,
Yeah.
in the third step, 3x minus 1 is less than minus 2 into that. So since like the denominator is negative, we're taking that x is less than minus 1. That means the denominator of the original equation will be negative. So we'll have to change the sign ka direction, right?
Which step can you tell me? So this step to this step?
No, 1 second.
Okay, so 3x minus 1 greater than minus 2x minus 2. Yeah. Now I'm not dividing anything, right? I'm adding 2x to both sides. When I say I'm bringing the minus 2x to the left side, I'm adding 2x to the left side, isn't it? So which step you're from here to here, is it?
Oh, have you done it like in a... I thought you just like, then after the second step, I thought it's like, it's a different thing only. I thought you've just taken the equation and put it into the third step, like the original equation.
I'm not clear which step you, so let's number this. Okay, so you want to annotate? Yeah, tell me. Okay,
I
yes.
thought like you did it like this, like this is the step
He
number
didn't.
2, it ends here, and then you took this part here.
No,
Uh,
but that's what he has done.
Okay, maybe I'll just quickly explain. It's much easier that way, right? So I'll just erase this. 1 second, Kunal. So can you erase your stuff? I'm not able to
Yeah,
erase
yeah,
your
yeah.
stuff. Okay, so I'm operating in the region x less than -1. So in the region x less than -1, that means x plus 1 is less than 0, correct? In this region, correct?
Yeah.
X plus 1 is less than 0, which means mod of x plus 1 will be negative of x plus 1. Do you agree? In this region.
Yeah.
Okay, so
Yeah.
that's it, the end of statement. Now I'll come back to the original question and I'll say, since mod of x plus 1 is effectively minus of x plus 1, I'll replace mod of x plus 1 with minus of x plus 1. And then I'll solve this problem without a modulus, a simple Sida Sada problem without modulus.
No, so but like see in the original equation, if we are taking that x is less than -1, that means the denominator in the original equation is negative. So when we are taking,
You mean the original equation like this one?
yeah.
The denominator is always positive because you have an absolute sign, which is
Oh,
why
but-
I safely multiplied.
Oh, but like
Because-
if you're taking that it's less than -1.
Even then, because of the absolute value, the denominator is always positive. I started off by saying that mod of x plus 1 will always be positive. X plus 1 could be positive or x plus 1 could be negative. Does it make sense, Kunal?
Okay, yeah, fine.
Understood, right? The original question, the denominator was mod of x plus
Yeah,
1, which
okay.
is why I could safely multiply and say the signage from here to here does not
Yeah.
change because I'm multiplying both sides with a positive quantity, namely
Yeah,
mod of x plus
got it.
1.
Yeah, sorry.
Yeah. No problem. All right. So 7 is done. Let's skip 8. We'll come back to 8. Let's finish some of the inequality problems. I want you guys to get a solid hang of all these inequalities. Can we do 9 for people who have not done it? For people who have done it, you can call out your answer. Anyone who has done it, call out your answer.
So
I
will
feel
you
that
discuss 8?
no, I skipped 8. We'll come back to 8. I
Okay.
want to discuss this inequality type of questions first.
So I
Yes,
got
I did 9.
x is greater than -6.
X is greater than -6. Okay. Avinash, what did you get?
So I'm trying to see if I've done it or not. I'm just looking in my book.
Okay. All right. Yeah, so this sort of thing is difficult to check, Ananya, but you can just put some random number and check, right? X is greater than -6. Okay, fine. The thing not to do in this case is cross multiply because, so Kunal, back to you. In this case, I cannot say 2x minus 3 times x minus 2 is less than 2x times x plus 2 by cross multiplication. I cannot do this cross multiplication because I don't know x minus 2 will be positive or negative, x plus 2 will be positive or negative. I don't know that. Does it make sense? Right? In the previous question, I could do because the denominator was granted to be positive for me. I was assured because of the modulus. Okay, so this is the step not to do for whoever is yet to begin or whoever has done it. So Ananya, hope you did not start with this, right? You did not cross multiply. Wonderful. So we'll discuss. Okay, anyone has an answer yet? Other than Ananya who's called out her answer? Okay, Ananya, one thing I can say, I don't want to nitpick again, all right? If you write this answer, it is, maybe it's x greater than -6, but definitely x cannot be 2. X cannot be -2. Because if it is, then the denominator will go to infinity, right, or undefined. So even if x greater than -6 is right, you should explicitly exclude these values. X equal to, x cannot be 2, x cannot be -2, right? All of you heard that one, right? Whatever the comment I made. Kunal, you understood, right? Even if x greater than -6 is the answer, she should exclude values which will make denominator 0. Kunsh, anything from you yet?
I'm thinking. I have an idea, but I'm not sure if it's the correct way to go into it. So I'm just working at it.
Okay. Okay, if people are not clear the first step would be to bring this entire region to the left hand side and say is less than 0. So something minus something is less than 0. Yeah.
I just solved it, but I'm not getting the last step, what I should do. Just
Okay.
forgot what to do as the last step.
Okay, we'll discuss. Does anyone want me to hold or shall we start discussing, guys? Anna has
So can you hold a minute, sir?
1 minute. 1 minute is all I'm going to give. Okay, all right.
Sir, I got x is less than -2 and x is greater than 2.
X is less than -2 and x is greater than 2, which means
Yeah.
any values other than the ones that will make this. Oh, okay. Any values between -2 and 2 also you're ignoring. Okay. All right. Let's discuss, guys. Okay. So these are the answers at the top. One is Ananya's and one is.
So I got an answer.
Go ahead, please.
So I got my -2 greater less than x less than 2 and x is less than 6 upon 11.
Okay. Or you mean
Or yeah.
X is less than 6 upon 11.
Yes.
Okay.
I
So
think that will also fit in the same region, right?
okay. So you tell me. So it's okay. Let's analyze.
I don't think this works.
Yeah, no, whether it works or not, let's analyze what Avinash just called out. So he's saying it's between -2 and 2 on one hand, right? And he's using the word or, which means he'll accept anything which belongs between -2 and 2 for sure. But in addition, he'll also accept anything that's less than 6 by 11. So 6 by 11 is a fraction which sits here. He'll accept anything which sits left of 6 by 11, which means his effective answer is anything between -infinity to 2, he will accept. Does that make sense based on what you are saying, Avinash? I'm just stressing this so that you know how to combine different parts of a solution using
sir.
and or and all that, right? So his effective answer would translate to this, if this is what he means. Agreed, Avinash?
Yes, sir.
Okay, let's do this now. Okay, so I'll bring everything to one side. So x plus 2. Anahat, you have anything, by the way?
I do, but it's very weird. So I think it's probably wrong.
Okay, let's discuss. Okay, so I'll get everything to one side and then I'll not cross multiply, common denominator this. Okay, and then 2x minus 3 times x minus 2 minus 2x times x plus 2. So let's expand the left hand side, this one. So 2x times x is 2x square. And then we have 2x times minus 2, which is minus 4x, minus 3x. So minus 7x plus 6. Okay. And then we have minus 2x square minus 4x. So effectively, I have minus 11x plus 6 upon x plus 2 and x minus 2. So I have all the key numbers in Avinash's solution. So 6 by 11 is definitely at play, minus 2 is at play, 2 is at play, but have we got all the sequencing correct? That's the main thing, right? All right, so let me put every number that causes any expression to become 0 will be active participant in this, right? The numerator will become 0. So numerator has only one term, minus 11x plus 6. By term, I mean a multiplicative term. Denominator has two terms, something times something. Numerator is only one something, minus 11x plus 6. That's one multiplicative expression, right? Even if it has 5 terms, collectively, it's all plus, plus, plus. Ultimately, it's one multiplicative expression. So that expression becomes 0 when x equal to 6 by 11. So I'll mark 6 by 11. And then don't mark 0 on the number axis at all, because unnecessarily that will confuse you. 0 is to be given as much importance as any other number. So 0 is not anywhere here. So in this problem, 0 won't come. 2 is here and minus 2 is here. Okay, now we'll look at the signage of this expression, right? And different parts. There are 4 regions, but once you do one region, everything else automatically comes, right? So let's look at the easiest region, which is x greater than 2. Let's say x equal to 100, right? So that you don't have to manually work out what the value is. I'm choosing a big number so that I can safely say it's positive or negative. All you care is it's positive or negative. If I choose x is greater than 2, like 100, then the numerator is a negative quantity. The denominator 200 plus 2 is positive. 200 minus 2 is also positive. So net effectively, it's a negative answer in the region greater than 2. Once you have one region covered, all the other regions will alternate. Between 6 by 11 and 2, it will be plus. Between minus 2 and 6 by 11, it will be minus. To the left of minus 2, it will be minus. So once we have this, now we can pick and choose what do we want. We want this quantity to be less than 0, right? We started off by saying this quantity should be less than 0. So we'll pick the region which is this, or the region between minus 2 and 6 by 11. So I should write minus 2 less than x less than 6 by 11, or x is greater than 2. That's the final answer. Does it make sense, guys? Okay. All of you good on this?
Yeah,
Anahat?
sir, I got the same thing, but I just thought it was very weird. And by mistake, I think I did 11 upon 6 by mistake. I just didn't write in.
Oh, what do you mean by weird? I mean, they're all just numbers, right?
I know, but
Just a
it
simple
didn't seem
fractions.
right. I just thought that
And by the way, 6 by 11 is something Avinash also called out. So if you got 11 by 6 or 6 by 11, it should not have been surprising, right? So it is okay. Anyway, so good. All of you know how to do approach this, right? Whether it's modulus or without modulus, how to approach this kind of problems. Okay, Avinash, you're completely convinced on this one now? Kunal?
Yes.
Kunal, you're okay? Kunal, your video is off, beta. I don't know why. Hope you're listening. Apurva, all okay? Okay. All right. That was question 9. Question 10, which is just a quadratic inequality, which would be much simpler. Again, I'm going to call on Ananya and few others only who have attempted it. Ananya, what is your answer on this?
So I got x is less than 4, or x is x is greater than 4, or x is greater than minus 4 by 3.
Like this?
Yes, sir.
X is greater than 4 or x is greater than minus 4 by 3. Okay, before even we delve into this, again, let's understand. Suppose this were the right answer. So I can blindly tell it's wrong because of this. Right. This is a number line, Ananya. Okay, so x is greater, 4 is here, minus 4 by 3 is here. You are saying you'll accept any answer which is greater than minus 4 by 3. Okay, I cannot say you're wrong. All I'm saying is, okay, you listen to me, right? Or x greater than 4, which means you'll accept any answer which is greater than minus 4 by 3, or you'll accept any answer which is greater than 4, which means this becomes redundant. You might as well say, you don't even need the or. You might as well say x greater than minus 4 by 3. Does it make sense? Right? Because, yeah, understood, right? So there's no point saying x. So it's like saying x should be greater than 10 or x should be greater than 7. If x is greater than 7, automatically, sorry, x is greater than 7, it accommodates for numbers greater than 10 also. Plus, in addition, it also covers numbers between 7 and 10. Same thing, right? Minus 4 by 3 is a smaller number. Because of the or, effectively, it's x is greater than minus 4 by 3. Similarly, Had you called out your answer as and, for example, then I would question you in the reverse direction. Why should you even mention x greater than minus 4 by 3? If you want x greater than 4, then the intersection of these is effectively x greater than 4. In that case, x greater than minus 4 by 3 would become redundant. Does it make sense?
So then how do I know if it's and or?
Okay. The problem is okay. So if you have a problem, all of the problems, how did we do? If you have a problem and then you mark this region is our favorable region, or this region is our favorable region, right? So this is an and, right? Because you want it between this and this, right? You want it between -3 and +1, or you're okay with it being greater than 7. So the English language itself will guide you. You're okay with a number between -3 and 1, or you're okay with the number which is greater than 7. So if you say it out, get your answer there. It must be greater than 3, right? It must be greater than -3, but less than 1, which means and, right? -3 less than x and x less than 1, or x greater than 7. So to answer your question, if you call it out aloud, you'll get your answer yourself.
So,
Yes.
so I got an answer. I
Which
just
is?
solved it right now. I got x is greater than 4 or x is less than -4 by 3.
I
Okay.
got the same answer.
X is okay, and you're putting or. Okay, this makes sense. I'm not saying it's right or wrong, but at least it makes sense. He's saying it's either this or this. Ananya, does it make sense? The or versus the and. Kunal, you as well, right? Right? So he's saying or. Okay, let's solve this now. So I'll bring everything to one side. 3x square minus 8x minus 16 is greater than 0. Always try to get everything to one side and you only have 0 on the other side so that the sign test can work. So here, how can I use the sign test? I'll assume this is equal to 0 and solve like a quadratic, right? So quadratic will be 8 plus or minus root of b square minus 4ac, 4 into 3 into 16, negative, whole upon 2a, which is 6. So 4 times 3 is 12. 12 times 16 is 192. 192 plus 64 is 256, which is 16 square. So I have 8 plus or minus 16 upon 6, which is 24 upon 6, which is 4, or minus 8 upon 6, which is minus 4 by 3. So I have the numbers 4 and minus 4 by 3. Right now, have they put it in the right way? We'll check. Minus 4 by 3 is to the left, right? And 4 is to the right. And it's an upward going parabola because 3x square. So this is how this function is going to look, right? And now you are questioning, when is this function greater than 0? So it is greater than 0 in this, when I say this function, it means the y value, right? The y value is greater than 0 in this region. And how do we determine this region? Anything to the left of minus 4 by 3 or anything to the right of plus 4. So your answer is right. Well done, Apurva. Okay.
Thank you. So I also, the way I did it was instead of graphing it, I factorized it and then I did the alternative plus minus plus.
Perfectly fine. Yeah, perfectly
okay.
fine. So I didn't feel like factorizing, but if you did
Yeah.
factorize, so 3 and minus 16 is minus 48.
And
I'll
then
have to find two numbers which add up to, yeah. So add up to, so minus 12x and plus 4x minus 16. So he factorized it as 3x times x. Let's do that also, right? Plus 4 times x minus 4, right? And then, so basically he said 3x plus 4 times x minus 4. And all along the right-hand side is greater than 0, greater than 0, greater than 0. Right, greater than 0, greater than 0. And then he'll use the same sign test, right? Minus 4 by 3 is here, 4 is here. If I pick a number greater than 4, let's say 100, so that we are safe. Positive times positive is positive. So here it will be positive, here it will be negative, here it will be positive. We can use the same approach consistently. Yeah, all good? Kunsh, you're okay?
Yes, sir.
Okay. And then the one question that we skipped in between was question 8. Which is the somewhat like the telescopic cancellation, right? That we had. Okay, so was anyone able to do this one? Ananya, were you able to do this one?
So I got A is half and B is minus half.
Okay. A is half and B is minus half. Okay. Okay, let's do this. Okay. Or you guys want time to do?
Oh,
Anahat, did you do this one?
So I got A is 1 second. A is 1 over 2n plus 4 and B is 1 over 2n.
You got A is what?
1 over 2n plus 4 and B is 1 over 2n.
1 over 2n plus 4 like this.
Yeah.
But A and B are constants. They cannot be
But-
dependent on n.
Yeah, but I just thought that that was the thing because realistically you can't just have some values which will always
No, you
because
can
have
have.
to multiply by n minus 2 and n draw.
No, you can have. That's the beauty of this. Okay, let's do this, right? So first step, find, he's asking us to forget this problem and just focus on this one, right? Find A and B such that 1 by n into n plus 2 is this, right? So I'll bring this here, right? So if I take the right hand side, n into n plus 2, right? So if I cross multiply, I get A times n plus 2 plus B times n. Okay, so let's collect all the n terms together. So which means
Oh,
A plus
Sorry
B.
to interrupt, but I got an answer just now.
Okay, what is that?
So I got A is equal to 0 and B is equal to 1.
All right, let's check. Okay, clearly that is wrong, right? Because if that were the case, then it'll be 0 by 1, 0 by n plus 1 by n plus 2. So you're saying 1 by n plus 2 is same as 1 by n into n plus 2, which is wrong, right, Rapurva?
Yeah, I forgot to like double check it. I was doing it quickly, so I forgot.
Yeah.
Sorry, my bad.
No problem. Okay, so continuing along here. So we have A plus B times n plus 2A, okay, upon n into n plus 2. Now this guy must match 1 by n into n plus 2. So back to what Anahat you were saying, I can treat this as 0 times n plus 1. So if things have to match, my A plus B times n, or rather, my A plus B must match whatever multiplies n. And whatever is the constant 2A, that must match the constant here, which is 1. So 2A should be 1, and therefore A is half. So you are right, Ananya. And then A plus B is 0, and therefore B is minus A, and therefore B is minus half. So you're right on this one as well. Well done, Ananya. Okay, so it's half by n plus minus half by n plus 2. Does it make sense, Anahat?
Yes, sir.
Okay, cool. Now comes the next part, hence show, which means you're supposed to use the earlier result, right, for the hence part. Okay, so let's do that. So which means every term
So
here.
can you just repeat how you got this A as 1?
Okay,
2A
so
as 1, sorry.
yeah, because I have an expression which is A plus B times n plus 2A.
Yes.
But on the other hand, I have just 1 on the left hand side, which means I can pretend it's 0 times n. If this has to be true for every n, right? Then that means my A plus B must match 0.
Yes, sir.
There is no n at all, right? And my
Yeah.
2A must match 1, and then simultaneously solve them.
Okay.
Okay. So now that I've got half and minus half, let me just clear space. I'll erase this. Guys, if it's okay. Okay. So I have space for this one. So it's half by n plus minus half by n plus 2. So every term is n and n plus 2, n and n plus 2. Okay. So the first term would be half by 1, right? Minus half by 3. Okay, I'll write it as minus like this. Okay, and the second term would be half by 2 minus half by 4. The third term would be half by 3 minus half by 5, and so on. Okay, the last term would be half by, actually, let's do the last couple, right? So the term before the last would be 1 by n minus 1 times n plus 1, right? So that'll be half by n minus 1 minus half by n plus 1. And the very last term would be half by n minus half by n plus 2. Now when we add all of these, the classic telescopic cancellation, right? So let's start cancelling. Minus half 1 by 3, half 1 by 3.
Wait, sir, sorry, how do you get these numbers?
Because I have half by n plus minus half by n plus 2 as the expansion of 1 by n into n plus 2, right?
Yeah.
So I'm applying it for each of them. Each of these,
Okay, you're just subbing in the back. Okay.
yes, right? So I can see a bunch of these cancellations, right? So you can half by 4 will appear here. That will cancel off here, right? Right. So everything will cancel except, so this guy does not have a cancellation. This guy does not have a cancellation. And similarly, things will cancel. This guy will not have a cancellation. This guy will not have a cancellation. You can see that, right? Things are canceling till here. If you look at the first cancellation, that'll give you an idea, right? The very first cancellation will change colors. The very first cancellation was between this term and this term, right? Which means the very last cancellation will be between this term and this term, 2 above this, right? The one above this, right? So, and then the second cancellation was this, third cancellation of this, right? So it's going like 2 off instead of 1 off. So the first term of the first 2 terms and the second term of the last 2 terms. So that's half plus 1 by 4.
And
which
we
is,
count the minus as well, right?
when you say minus, the plus and minus is what's cancelling.
No, like it'll be minus half upon n plus 1, right? Or is it just half upon n plus 1? Those 2 terms at the bottom.
Yeah, the minus will count. Minus will count. Yes, absolutely.
Yeah.
Minus will count. Oh, sorry. Yeah, I should have put with the minus. Yeah, good point there. Yes. So the answer is half plus 1/4, and then minus, like you said, I'll put the minus. So 1 by 2 into n plus 1, and then 1 by 2 into n plus 2, right? And that's what we have it here, right? So this is 3 by 4. This is the 3 by 4, and then 1 by 2 times n plus 2, 1 by 2 times n plus 1, and right? We got the same answer. And the potential further question could be, as n tends to infinity, what happens, right? As n tends to infinity, this guy will go to 0. This guy will also go to 0 because you have a large number in the denominator. So effectively, this will converge to 3 by 4 after a large number of terms. That could be another question as well. Make sense, everyone? Okay. All right.
Yes.
Okay. So let's switch gears to geometry. That's what we wanted to do today. Okay, so let's start with basic triangle. So in triangle, let's start with labeling of a triangle, right? So capital letters are used for the vertices. Small letters are used for the corresponding opposite sides. And sum of any 2 sides must be bigger than the third side, right? And it's enough to write a sum of the small and the medium is bigger than the large, because obviously if you have the large number and you're adding with another number, it obviously will be bigger than the other one, right? So you can just say if it's a scalene triangle, the small and the medium should add up to strictly more than the large. Otherwise, you cannot form a triangle at all. If you have 3 pieces, let's say I have a piece of length 3, another piece of length 5, another piece of length 9. If I try to make a triangle, if I lay the 3 here, and even if I put the 5 just flat across, I cannot fit a triangle, right? And let alone if I tilt it in a triangle, it will be even harder, right? It won't be able to, right? So it must be strictly less than 3 plus 5. So only if the third part is less than 8, I can form a triangle. Okay, that's very basic stuff, all of you know. Okay, so in a triangle, we have 4 important lines. By that I mean like median. So we have median, we have angle bisector, and then we have perpendicular bisector, and we have altitude. Okay, so each of them has 1 or 2 important properties, right? So what's a median? Median is you're connecting to the midpoint of the opposite side. So this is the median. Okay, so this is a median, and this will be a median. So all the 3 medians will intersect at a point. That point is called the centroid. Okay, it's the center of gravity. So I'm just calling it G here, right? In this case, G, center of gravity. So if you form a cardboard paper with this triangle and you want to balance it in the tip of your finger, you'll have to hold it at the center of gravity. If you hold it, that will be staying stable there. So this is center of gravity. The main point here is the ratio of AG, let's call this D, E, and F as the intersection points. Okay, AG is to GD will be 2:1. Likewise, for any other two ratio, BG is to GE and CG is to GF. Okay, this is, by the way, this is small c. This is the side small c. This is the point capital F. So CG is to GF. All of these ratios will be 2:1. That's the main property with medians. Angle bisectors. Sorry, what happened? Right. So if I have an angle bisector which goes from here to here, right? The main property here is, Rohan, do you recall? Anyone? Anahat?
Sir, can you label the sides, like label all the things and I can say, but
Okay.
AB by BD is equal to AC times CD, I think.
AC upon CD, correct. AC upon DC, let's say. Okay. Either you can, so this upon this is same ratio as this upon this, right? Equivalently, some people like to remember in this way, AB by AC, the ratio of the two sides into which this angle bisector divides. So this is an angle bisector, right? Is same as the two parts into which the opposite side gets split, PD upon DC. So both are same only, right? If you see, I'm just bringing the AC down here, I'm bringing the BD up. That's the only difference, right? If I bring the AC here, if I bring BD up, that's same as the second equation, right? That's an important property of an angle bisector. Now, obviously, all the angle bisectors, not obviously, all the angle bisectors also will meet at a point. So let's say I connect all the three angle bisectors. Okay, let's say this is the second angle bisector and the third angle bisector is like this, let's say, right? So I didn't draw it well, but let's say it meets at this point, right? That point is called the in center. In center. So all the angle bisectors meet at in center. I'll mark this point as I, capital I. Okay, so the main property there, why is it called in center? Because I'll be able to draw an in circle, right? In circle means a circle inside the triangle, which is just touching all the edges, which means if I draw the perpendicular from here, this length, if I draw a perpendicular from here, this length, if I draw a perpendicular from here, this length, all of these will match, which will enable me to draw a triangle, sorry, not triangle, circle inside this triangle. Hence the name in circle. So I'll be able to draw such a circle. So this circle is called the in circle, and this has a radius, right? That radius is delta upon S, where delta is, I think I said somewhere before also, I'm not sure. Delta is the area of the triangle. So delta is the area. In general, delta is used for area, right? So dimensionally also you can check. So delta upon S is semi-perimeter, right? So dimensionally also you can check area upon length. Area is length square. Perimeter, semi-perimeter is just a length. Length square upon length is a length, right? So dimensionally you can also do a basic check. And this is the radius. This is the radius of the in circle. So it's denoted with small r. And you can, depending on what the triangle is, you can use multiple ways to find the area. Let's say all the sides are given. You can use the standard Heroin's formula, which is S into S minus A into S minus B into S minus C, right? Okay, so actually, where is this coming from? So for example, let's take this point as I said I, right? So if I look at the triangle BIC, okay, the area of triangle BIC would be what? Half into BC into the height, right? I'm saying this is the height, which is R. Half into BC into R. That's the area of triangle BIC. If I take the triangle AIB, right? AIB, the triangle to the left here. Same thing, the base would be AB and the height would be R. Only then you can draw, the height is supposed to be perpendicular to the base, right? Only then the circle will be tangential. And similarly, triangle AIC ke liye, the base would be AC and the height would be the R again. So if I add all of these, it becomes the triangle of the entire triangle ABC. right? That's what I'm calling by delta, right? Which is just denoted by delta. So that is your R times half of AB plus BC plus CA, AB plus BC plus CA by 2, right? So which is your S, right? So is, in other words, this is your delta of the area of the triangle is R times S, and therefore you get R is delta by S, right? So the area radius of the thin circle is delta by S. Okay, and then the third part is the perpendicular bisector. So perpendicular bisector mean, in general, what does perpendicular bisector mean, right? So perpendicular we all understand. So if you have a line like this and this line is perpendicular, okay? Bisector, it's not like both have to bisect, right? Right? So I can have a line like this and this line is bisecting this line, not the reverse, right? So bisecting need not be dual, it need not be, that word is reflexive, right? If a line A bisects B, it's not necessarily line B bisects A, okay? So perpendicular bisector means it has to be perpendicular and bisecting. Perpendicular to what and bisecting what? The side, of course, right? So if I have a triangle ABC here, triangle A, B, C. Okay, so I'll take this side, I'll draw a perpendicular bisector, which is this way. It has to be perpendicular as well as bisecting. I'll take this side and draw a perpendicular bisector. It has to be perpendicular and bisecting. Okay, and I'll take this side and it has to be perpendicular bisector. If I drew it well, then it should come, but I didn't obviously draw it very well, right? So thoda aage piche will be, right? But point is, all the three perpendicular bisectors will meet at a point. So that point is called the circumcenter. So it's the meeting point of the all the three is perpendicular bisectors. So ABC, circumcenter. I don't want to use the word C again. Okay, I'll just say D. Fine. Okay, so D is the circumcenter. The reason it's called circumcenter is you can draw a circumcircle or a circle which circumscribes this triangle, right? So again, the three lengths from D to B, D to A, and D to C will all be same, which is why it enables me to draw a big circle around this, right? So like if I draw a circle around this, oh, sorry, maybe not a good color. Pick this one, right? I can draw with D as the center. I should be able to draw a circle, and this is a hopeless circle, but fine, right? It should touch A, B, and C and draw. Okay, so this circle has a radius, right? That is denoted by capital R. This is one place where there's a slight variation, right? So generally we use small letter for lengths and capital letter for vertices, but circumcenter alone is a weird place where we use capital letter to use a length, right? Capital R is the radius of the circumcircle, and that also has an interesting formula. We can skip the derivation of this. ABC by 4 delta. Okay, A, small b, small c are the three sides, and we can just check, right? The length times length times length is length cube in the numerator, and denominator you have a area. 4 is just a number. Length cubed upon length square is length. So dimensionality check passes. ABC by 4 delta. Okay, altitude, there is not too much, but the meeting point of all the altitudes is called the orthocenter. I mean, there are some properties, but for AMC10 you can ignore. So you have.
Could you show the formula for circumcircle again?
Yes. Okay, so it is ABC by 4 delta.
Okay, sir.
Okay, the altitude is right. Altitude is from the vertex. It has to be perpendicular, right? Obviously, it's not guaranteed to bisect the base. In this case, you can clearly see, right? The base is not getting bisected. And from this, you draw up a perpendicular. And from this also, you drop a perpendicular. So all of these will meet at a point. So that point is called the orthocenter. So meeting point of altitudes is called the orthocenter. There are some properties, but you don't need to worry, right? Orthocenter. Okay. Now, for an equilateral triangle, obviously all of these will coincide because of the symmetry. All of these will be coincidental, right? In fact, even for an isosceles triangle, so let's say I have an isosceles triangle like this, right? Isosceles triangle like this. Right? So if I draw a median or an angle bisector or a perpendicular bisector or an altitude from the top, they're all same. It's just this one line, right? But of course, it's not the case for the other two. For example, the angles bisector of this one will look something like this, right? Whereas the median would look something like this, right? So the other two sides won't be same. But for the side which is symmetric, or rather from the vertex where there is symmetry, then all the four will be same. Okay, and for equilateral triangle, all four of them will be same. And we can just do a simple check for an equilateral triangle, whether the encircled radius and the circumcircled radius make sense. Let's do that, right? Let's go back to an equilateral triangle. So I'll draw an equilateral triangle here. Okay, and let's say I draw whatever the median or whatever you want to call it. All of them are same anyway. So let's draw that. We'll call it median or angle bisector. Doesn't matter, right? Okay, now, so you have A, B, and C. Okay, now this is 30 and 30 by symmetry, right? Similarly, 30 and 30. So you have a 30, 60, 90 triangle here. So this is 60, right? How do you know this is 60? Because you have 90 and 30, right? So you have all the angles which is symmetry. All the angles are 30, 60, 90. And therefore, you can use your property of 30, 60, 90. What is that property? For any 30, 60, 90, the ratio of the three sides will be x is to x root 3 is to 2x. We have covered this a few times, right? So the one opposite to 30 will be the smallest, which will be x. The one opposite to 60 will be root 3 times that. The hypotenuse will be 2x. So let's use that property here. So let's say the side length is s for the equilateral triangle. So this is s by 2 and this is s by 2. Now, if I look at the bottom, okay, let's call this G, right? If I look at triangle BGC, okay, now this is the hypotenuse, which is S. Sorry. Okay, that's not the that's hypotenuse, but what I marked is wrong, right? So the S by 2 corresponds to the one opposite to 60 degree, right? S by 2 is the one which opposite to 60 degree, which means this will be S by 2 upon root 3. Correct? S by 2 upon root 3. So when you multiply by root 3, I get the one which is opposite to 60. Avinash, you're with me? Right? The ratio is 1 is to root 3. And the one which is the hypotenuse will be twice the smallest one, which will be S by root 3. S by root 3. Now, what is the encircled? The encircled radius is this. This is the encircled radius. S by 2 root 3. Is that what we expect? Let's check, right? We expect the encircled radius to be delta upon S. Or maybe I should have not chosen S here as the side, because S is also semi-perimeter here, right? So I'll replace all the S's with, I don't know, what should I call it? I'll just call it A, okay? A by 2, A by 2, A by 2 root 3, A by root 3, okay? So the encircled radius, just by observing here, because the encircle will have a radius like this, right? So I should be able to draw an encircle like this. So the radius for that is just GD, right? Which is A by 2 root 3, as we just saw. Now let's verify whether we get the same answer. We know it's delta by S. Delta for a equilateral triangle is what? Height times half into base, which is A, times the height. And what is the height? So height, if I look at the triangle ADB, ADB is another 30, 60, 90 triangle, where A by 2 is the smallest, right? which is opposite to 30 degree, right? Therefore, AD, which is opposite to 60 degree, will be A by 2 times root 3. So this 1:√3:2 comes in handy multiple places. Apurva, are you with me, right? Completely, right? So the height can get replaced with A times root 3 by 2. So the area of an equilateral triangle is root 3 by 4 times side square. So root 3 by 4 times A square. That's the delta upon the semi-perimeter is A plus A plus A by 2, which is 3A by 2. So let's simplify this. So root 3 by 4 into 2 by 3, A square by A is A. So does this give the same answer as here? Let's check. A is there, then this is 2. And then if I cancel the root 3, indeed, it's A by 2 root 3. So it matches, the formula matches with what I'm just able to see just visually as well. Okay, Ananya, are you with me completely? Okay, let's verify that the circumcircle radius also matches. Circumcircle radius should be AG, right? This length is the circumcircle radius, which is same as this length, BG, which is same as GC. So I should be able to draw a circle with that as the center, right? So I should be able to draw a circle with like this, right? So that's a circumcircle, right? So let's verify the formula again, right? So just looking at this, I can see this is what? A by root 3, right? We just saw this is A by root 3. This is A by root 3. This is by symmetry, A by root 3, A by root 3, A by root 3. So capital R is A by root 3, just by looking at it, right? AG, BG, and CG, they are all capital R. Now let's see, the formula gives the same thing. R equal to ABC by 4 delta. ABC is A into A into A in the case of equilateral triangle. So it's A cubed by 4 times delta we just saw is root 3 by 4 into side square. So 4 gets cancelled. A square gets cancelled with A cubed, giving A by root 3. So indeed, the circumcircle radius also matches as expected, A by root 3. Okay. Right. What else is there in triangles you should know? Okay, 45, 45, 90, you guys know, right? For a 45, 45, 90, which is isosceles right angle triangle, the ratio will be x is to x root 2. That's very obvious. Okay, now the next one is Pythagorean triplets. So the common triplets you guys know are 3, 4, 5, 5, 12, 13, right? 7, 24, 25, and they have a certain pattern, right? So can someone complete the next one? And anyone knows the next one, next series in this? Anahat, do you know what's the next Pythagorean triplet in this series? Or Rohan, can you see a pattern? Okay, I'll do one more. Yes.
Yeah, 9, 40, 41.
Okay, what is the pattern?
Basically the last two are 1 apart and the first section is 2 apart.
First section is 2 apart, 3, 5,
So
7.
would the next,
And for the middle row, it's multiples of like 4 times 3, 4 times 6.
Yeah.
Oh wait,
Okay.
that's 4 times 10 and then yeah.
so the next one I think would be 11, 60, 61.
You're right. But then do we have to go one at a time? For example, way down here, suppose I have 23 here. What will this and this be? We have to go through every one of them. Yes, both your observations are right so far, that these two are consecutive numbers, and this is increasing by 2, 2, 2, 2. But if I have to go to 23, what will these two numbers be?
You can find that out because you know the n value by using patterns. So 2n plus 1 is equal to 23. So n is 11.
Yes.
And then you can use that n value in each of the other patterns.
What is the other pattern? So what I'm saying is these two are consecutive numbers, but what does this have to do with n? That's my question. You understand my question, right, Rohan?
Yeah.
Okay. Or in other words, in any row itself, can you connect the 3? Yes. Right. So these two are adjacent numbers, but anything else that will connect these two with 9. Oh, few people have left. I'm not, I just noticed. Okay.
If you add 40 and 41, it's equal to 9 squared.
Exactly. So 11 square is 121, which is this. So 23 square is 529, which is 264 and 264, right? 265 are two numbers which add up to, right? So there'll be 264 and 265. So in general, the observation is a triplet is, if I can start with any odd number, which is 2n plus 1. Okay, I can square that odd number, 2n plus 1. When I square, I get 4n square plus 4n plus 1. Okay, and now suppose I divide into two equal halves, then it becomes 2n square plus 2n plus half. But rather than put half, I'll just say 2n square plus 2n plus 1 and just 2n square plus 2n. These are consecutive numbers. So my claim is a triplet is 2n plus 1, 2n square plus 2n, and 2n square plus 2n plus 1. This is a triplet. Now, let's validate this claim. Okay, so suppose this is small a, this is small b, and this is small c. So my claim is a square plus b square equal to c square. Let's verify that. So in other words, my claim is c square minus b square is a square. Okay, now can we check that? So if we do 2n square plus 2n plus 1 whole square minus 2n square plus 2n the whole square. So this is c square minus b square, right? Which is c plus b, which is this, times c minus b, which is just 1. And sure enough, this guy is 2n plus 1 the whole square, right? So indeed, it's a square. Indeed, it's 2n plus 1 whole square, right? So you start with any odd number, for example, 17. Square of 17 is 289. Split it into two equal halves, 144, 145. That will be a triplet. Okay, does it make sense? Kunsh, you're with me? Yeah? Okay.
Yes, sir.
But of course, you can take any of these numbers and multiply by some constant, right? I can say 30, 40, 50 is a triplet. I can take 5, 12, and 13 and multiply it by 2 and say 10, 24, and 26 is a triplet. So that way you can generate many of them. But independent of that, there is another way which is even bigger than, not bigger, which accommodates for these also plus a few more. For example, there is a triplet which is 8, 15, and 17. That's a triplet. 64 plus 225, which is 15 square, is 289, 17 square. So 8, 15, 17 won't come in this pattern. Similarly, there's 20, 21, and 29, which again won't come in this pattern. So what's happening there? So a more general Pythagorean triplet is the set of these numbers. Pick any number, any two numbers, p and q. Let's say p is bigger than q. P square minus q square, 2pq, and p square plus q square. This is a triplet. Okay, let's verify. Okay, so if you do p square minus q square the whole square, how much is this? P power 4 minus 2p square q square plus q power 4. And if I add 2pq ka whole square, which is 4p square q square. If I add these two, I get p power 4 plus 2p square q square plus q power 4, which is indeed p square plus q square the whole square. Right? So it's this guy getting squared. Right? So that's a triplet. So for example, what is that? 8, 15, and 17 I said, right? So I can say, let's pick p as 4 and q as 1, right? So p square minus q square will be 16 minus 1, which is 15. 2pq will be 8. And this will be p square plus q square, which will be 17. So I get the 8, 15, 17, right? I can get 20, 21, and 29. I can say p equal to 5 and q equal to 2. 25 minus 4 is 21. 2 into 2 into 5 is 20. Of course, it need not be in ascending order. The largest one obviously will be the last. P square plus q square will be the largest. 29 is the largest. And the normal 3, 4, 5, 5, 12, 13 also you'll get. For example, if I have to generate 5, 12, 13, I can say p is 3 and q is 2. So 3 square plus q2 square is 13. And then 2 into 3 into 2 is 12. 3 square minus 2 square is 5. So whatever you saw earlier can also be generated using this, plus a few more, like this 20, 21, 29, 8, 15, 17. So this is the most general way of generating Pythagorean triplets. Does it make sense? Okay. All right. Let's stop here. I think it's a good place to stop. Next week we'll cover quadrilaterals and few properties of quadrilaterals, and then maybe another 1 or 2 more sessions. I want to cover all the basics, and then we'll do topical questions for AMC10. Okay. Sorry for the delay today in joining. Bye. Good night. And Rohan, if it's not too much urgent, I'll call you a little later tonight. Okay.
Yes, sir.
Okay. Bye.
Bye.